I kind of hate to admit this, but some of my colleagues here will resonate with this. I've spent 4 decades now in the tech industry. It doesn't feel like it. I'm probably more excited about it right now than I've been in any of those 4 decades. But during that time, I've had an opportunity to witness a series of technology platform shifts. It started, I hate to say this too, but it started with the migration from CAD on mainframe to CAD on mini computers to CAD on desktops to desktop computing, client server, mobile, the internet, cloud computing, all waves that you're familiar with and have seen. And each one of these waves, as they occurred, they seemed to happen quickly at the time. They seemed to move fast. Every one of them created opportunity. Every one of them created risk. Every one of them, in some cases, created some fear. And while they seemed like they moved fast, and they certainly did inspire productivity and enable productivity, they inspired innovation, they certainly inspired spend on tech, which is where I spent my career. They didn't move as fast as what I think we're seeing right now with this latest wave that we call AI. And so I think that's why this conversation this morning is important. We don't want to have a roadmap discussion. We're not going to talk about features and functions in everybody's product. We want to have a bigger, broader discussion. Sorry, Jason.
We can do it.
Yeah, that's part of my job as moderator, by the way, just so you guys can help me if I need it. We want to ask bigger questions. We want to ask the questions really that will help to shape the decisions that you all need to make in the coming months, quarters, years, as you think about the strategy for your own businesses, as your customers think about their strategies, and the decisions that you make that will shape your own futures. And so we thought that it would be good to try to keep this focused on just 3 pretty big, broad topics. And the first one of those is going to be focused on sort of what's happening now, right? What's real in AI? What's just hype? Maybe what's vaporware? What's actually creating value in the industry? And to try to ground this in reality, because I think you all deserve a very clear-eyed view of where we stand right now. And sometimes I know it's difficult to separate the hype from the reality. So we want to try to do that for you to a certain extent this morning. And then the second topic, we're going to get a little dreamier. We want to talk a bit about, well, where is this going? And how will it impact your business? How will it impact your technology stack? How will it impact your customers? And how may they impact you with their own implementations of these technologies? And maybe dream a little bit about what's possible, and maybe talk a little bit about the practical realities in this industry of what may or may not happen. And so we hope to share some maybe some prognostication with you a bit this morning to talk about that. And then there's a third topic that we think is really important, particularly in this world of AI, and it's the topic of trust. AI comes in many different forms, as you all know. Many of those forms produce non-deterministic results. And so how is it in a manufacturing company that I can trust that? How is it in an engineering process that I can trust those results to actually perform in the way that a simulation says they will? And so we want to talk about that trust issue and what it might take for you all, for the industry at large, to trust what we get from AI and actually use it as either a decision maker or part of a decision-making process in an engineering and manufacturing company. Now, we're going to use some terminology up here. Right, John? We're going to use some terminology up here around AI. And so we thought about maybe we'd spend a few minutes at the beginning of this panel and review the glossary. And we decided, no, there's too many other important topics to talk about. In recognition that everybody here is at a different point on the learning curve and a different point on the interest curve of thinking about AI and the technology associated with it, we took the liberty of creating the AI glossary of terms. I hope you've all seen it in your packet. We all read it this morning for the first time. We learned a couple things, which was great. But I think it'll help ground the conversation because you are likely to hear some of this terminology. And we put it on a nice card that you can take with you and pretend to all your friends and colleagues that you've learned everything there is to know now about AI, which I don't think anybody in the world can actually claim. With all of that said, I'd like to introduce our panelists. I had this idea with Jason a while back about doing this panel. I thought, well, who could we get to do this panel for us? And I put together my dream team list of panel members for this conference. And sure enough, every single one of them said yes. So here they are. And so seated to my right here is John Stevenson. John is the Chief Product Officer of a little company here in Boston called PTC. At PTC, John's responsibility is the full gamut of the strategy, the delivery, the implementation of PTC's digital thread product line. John and I have a long history together. We worked together at PTC back in the 90s. And we had a lot of fun where the company was on a huge growth trajectory and we were both a very active part of the leadership of the company. And it was during the time when that company grew to over $1 billion in revenue. So it was really exciting. And John, thank you for being here. It's great to be on stage with you again.
I'm happy to be here.
I think you know the guy to John's right, Jason Ray. Anybody met this character before? Jason, as you know, is the CEO of Paperless Parts. Jason has been the driving force behind Paperless Parts since it was just an idea. From the very beginning of the company to now building the company into the leader in the manufacturing quoting software space. He has been thinking a lot about AI and thinking a lot about how AI can be delivered within the paperless product portfolio and how it will impact the industry at large. And so, Jason, thank you for joining the panel. It was great to have you here. Next to Jason, is Steffen Dilger. Steffen, welcome. Steffen comes to us from Hexagon, where he is the president of the production software division, and he joins us today from Frankfurt, Germany. So he made a long trip. We appreciate you making the trip and coming here to join us. Steffen has a long history of experience in operations and strategy, sales and marketing, leading the software efforts for Hexagon today. He also, as a younger man, was a semi-professional sprinter. So he is you didn't know this, did you, Jason? So he is no stranger to the level of hard work, precision, discipline, and speed associated with our industry and where it's moving today. So Steffen, thank you for being here.
That's it.
Thank you.
Thanks for being here.
Pleasure.
What's that?
We're sharing time.
Yeah, oh, good. All right. Were you a sprinter too?
No.
No.
To the bathroom.
You're not the, yeah, right. And to Steffen's right is Dr. Robin Tallui. Robin is a physicist by training. He is the founder and chairman of PhysicsX, a London-based company that is in the business of completely modernizing the world of engineering and production simulation through the use of AI. PhysicsX is a pure play AI company. Robin joins us from London. Robin has an extraordinarily interesting background in Formula One racing. And so I would encourage you to corner him after the session and talk to him about Formula One and Team Petronas at AMG. So Robin, thank you for making the trip from London. It's great to have you here and really appreciate you being on stage with us.
Thanks, Jim. Always happy to talk nuts and bolts on Formula One cars.
Yes. So I've been talking for a while. I'm going to stop doing that now because these guys are much smarter than me, and I would like for you to hear their side of this story. And so to kick this off, not that anybody here is shy, but I'm going to get you all talking a little bit here. I have a really simple question. On a scale of 1 to 10, 1 being low, 10 being high, how important is AI to your company's strategy? John?
10.
10. Jason?
Probably a 10.
Probably a 10. Steffen?
I would say 9 to 10.
9 to 10. Robin? Now, Robin comes from a pure play AI company, so I'm really interested to hear what he has to say.
1.
5.
8.
8. 8. Okay. So, all pretty high numbers. You know, as I observe here, it seems like this is a pretty important topic to some pretty important companies here in our industry. And every one of these guys has a well-formed opinion on AI and a lot of experience in what they're doing with it. So let's get started with the questions. So our first theme, as I mentioned, is this question of let's try to separate reality from hype. You know, what's creating value in the world of AI for engineering and manufacturing companies today, and what's not. And so, you know, it's really this question of, is it real, or, you know, is it overhyped, right? Do these things really do anything for us? And I'm going to start the questions with Jason. And then my job, by the way, is to control the chaos that ensues. So here we go, see how I do. But Jason, the conference theme, as you pointed out this morning in your keynote, is focus on what matters. And so in this market that's full of AI hype, what do you think is real today, and where are manufacturers actually starting to see value?
Yeah, thanks, Jim. So I try to be an AI realist because I watched the 3D printing bubble come and pop, and I listened to a lot of folks say, you know, additive manufacturing is going to replace all manufacturing and everything's going to be designed for additive. And it's kind of become a tool in the toolbox. So I look at AI as a tool in your toolbox that can make you more efficient. Now, what's real versus what's hype? I think the reality of AI is very good at rote, repetitive tasks, and you can absolutely take advantage of AI to streamline your workflows in your business. So I think that's great. I think you start to border on hype when you have your software companies telling you that we're going to turn you all into builders and you're going to vibe code all the things that we are underfunded or too lazy to produce ourselves. So we're going to pass that burden on to you. I don't think that is in alignment with focusing on what really matters, because I think the best businesses focus on what they are uniquely suited to do. So while you will be able to build software, I don't know I think that's where the hype starts to take over.
Any specifics, John, maybe of where you see AI today adding value in manufacturing and engineering companies?
Yeah. So our customers, I'm going to ground all of my answers in what I'm hearing from customers and seeing in customer deployments. And our customers are the biggest auto and aerospace companies in the world, like Blue Origin or Airbus, Volkswagen, BMW, Toyota. But our customers also include a lot of companies that are influential in AI, Microsoft, Meta, Amazon, NVIDIA, Google. And I feel when I talk to those customers, I'm getting it from both ends. The people that are pushing AI and then companies that have to consume it because they're manufacturing real products. And most of what's happening is real. We just don't see it yet. And that's why we continuously are surprised by its capabilities. But there are bounds to the technology. Jason mentioned one. The fact that it's indeterminate technology or it's probabilistic means that you have to work around those limitations to deliver predictable results. And that's what you're doing in paperless parts. I heard you talk about it this morning. And the other bounds, which can be proven mathematically, is that you can't train on every set of data to generate similar sets of data. Sometimes you need special applications like engineering analysis tools. And that's okay because you can combine that with AI to achieve real results. But most of what you hear is actually real. And Jason pointed out one of the things that isn't real. It's not going to replace every function. It doesn't replace human supervision. You have to be careful in how you deploy it because of the limitations of the technology.
Robin, you come at the problem at PhysicsX from sort of way upstream, right? Engineering simulation used in the design process, which can then be simulations, which can then be leveraged throughout the production process as well. And I wonder from your perspective, living and breathing the world of application of AI in these processes every day, what do you see as some of the more practical examples?
Well, when we talk about AI, mostly it's talked about in the context of language models, large language models, and how those help operational processes and whatnot. For PhysicsX, we're talking about physical AI. And, just to be a little bit controversial here, up until about a year and a half ago, Silicon Valley and the rest of the world thought that physical AI is robotics. Well, no, it's all the things that we make, right? It's all the parts that are made for automobiles, aircraft, spacecraft, and whatnot. Those objects, that's physical engineering. And PhysicsX is a physical engineering company. A third of our staff are engineers, simulation engineers, design engineers, because we are rooted in that reality. And so what is hype and what is real is absolutely the physical results that we produce. And I answered 8 on the previous question precisely because AI is in service of our physical engineering, from concept optimization all the way to manufacturing process or operational optimization. And understanding that and integrating AI into those workflows, so physical AI, so we call these large physics models. These are not large language models. Integrating that and creating the value pools along all of those steps and doing that a lot faster and a lot more optimized. I think that is the most important thing, and that is very much real. We can talk about that more.
I'm interested, as I put myself in the seats of the audience here, I'm interested in maybe, Jason, some of your thoughts on AI on the shop floor today. Like, what's it really doing?
Yeah, I think it's a great question. We're seeing it in a few different areas on the shop floor, and you have companies here that are actually pushing that with their ability to ingest data and help you make sense of what's happening on the shop floor, but it's only as good as what you can see. There have been a handful of startups that have come out using cameras to try to track people's motions, to understand repetitive tasks. You have machine monitoring, and these are all different inputs that can then be analyzed with AI. That said, we're not seeing AI today replace humans on the shop floor. I think there's, you're hearing biped robots are going to come in and they're going to run all the factories.
We'll get there.
Yeah. But I think at the end of the day on the shop floor, what we're seeing is better communication, and we're seeing faster communication, which is speeding up people in their ability to execute the tasks as they have to do.
Right. I talked about this long-term front row seat I've had to these various technology waves and platform shifts over the last several decades now. And I think one of the things that's characterized every one of them has been the question of economic value, right? So it's cool technology. I love it. Helps me write emails every day, answers questions that save me a bunch of time researching in Google. But from a manufacturing perspective, are we starting to see actual economic value? Are we starting to see the thing that will actually drive this technology into the mainstream, which is not cool features, not cool technology, but a real business imperative? And Steffen, I'd love to hear your thoughts on this.
Yeah, I think from my perspective, yes, it's creating value. But if you look how much goes down to an EBIT influence, certainly it's not as big as the hype might be yet, especially when it comes on the shop floor operations. But let's have a look a little bit where are the challenges. We all know we are living in a multi-crisis environment. Agility is certainly something which is super important for manufacturers in these days. Supply chains, volatility as we have, and in all that environment, certainly AI can help generate added values for us. It's not about only about speed, even if you know now speed, I like speed, but at the end it's more about also having a good foundation for sound decisions early in the process, basically, then also not doing the wrong decisions at the end. And I think here AI together, and my co-panelists have already said it, it's not about AI standalone, it's the human in the loop, basically. AI can help to aggregate things, to help you to take sound decisions early in the process. And then basically, but it's still the human who has to take the decision and to take the judgment. Otherwise, let's take an example, aerospace, for example, where you have really highly governed environment, basically. If AI takes a decision, who will sign the AD? A model? So somewhere you have a chain of custody and basically also humans verifying what AI is producing. And that's basically what we also see in our own environment, basically. In the CAM environment, you can, for example, easily today let your CAM program being done by AI. But after that, certainly, you need to have a verification step.
I think that my positioning earlier on, I made an assumption in one of the things I said, which was that AI represents a fundamental platform shift. And I believe that. I think we're seeing it every day. I think we're seeing it unfold faster than anything we've ever seen. But John, I think I can say this because we have a long history together. You and I worked at PTC into the early 2000s. And then you left, I left, you went and did other things. More recently, you've been enjoying life as a board member and as an investor and as an advisor. And something motivated you recently to jump back into the frying pan and become the chief product officer for a $2 billion, to almost $3 billion now, digital thread company, and take on leadership for their technology strategy. Does AI have anything to do with that?
It has
Is it that important?
everything
is
to
it a
do with
shift?
it. I think we're at a defining moment where everything's going to change again. And I think this is going to be a bigger transformation than what happened with the internet in the late 90s. I think this is a fundamentally different platform shift. And you talked about the shift from mainframes to minis to Windows-based machines and then to the internet. Those were all compute environment. This is more on the intelligent side and the logical side. So I think it's a bigger shift and more exciting.
Yeah. Okay. So with all of these big shifts comes vendor hype, industry hype, vaporware, stuff that people buy and are disappointed in because it doesn't do what the vendors claim.
Pets.com.
Where are we? What's hype versus reality today? What's out there today that you guys are seeing that just isn't quite matching the promise yet?
Well, I'll answer the opposite of that question. If you really want to know where AI is going next, look what AI is doing for software development, because it's a fundamentally easier problem than physical AI. And software is a language. It's governed by semantics and syntax. There's a lot of data to train on, and a lot of money has been thrown at this problem already by Anthropic and Cursor and OpenAI. And just in the last 9 months, in software development, we've moved from pair programming, people using GitHub Copilot, to autocomplete code or to generate test cases, which produced a productivity gain 20 or 40%, but caused bottlenecks downstream, to people using Claude Code to orchestrate agents to fully automate the handoff from testing to coding to user interface design and production to QA, so that you can have an autonomous program for generating code, but again, under human supervision. And that's a huge leap forward. It changed it from an individual productivity gain to an enterprise productivity gain. And I think the same thing is going to happen in other domains, including physical AI. So you can see what's going to happen by looking at the easier problems and then thinking eventually we're going to get there in our domain.
Jason, what do you think? What's hype?
Yeah, I think the economics are hype today. So I don't know if you've noticed, but Ubers have gotten a hell of a lot more expensive.
Yep.
That's because the subsidy is stopped. And I don't mean a government subsidy, I mean venture subsidy. So I go back to Amazon. So Amazon, $3 billion is what was the catalyst of that company. And they grew into what you have today, which is in a behemoth of a company. That is a small fraction, 1% of what's going into the Anthropics and the OpenAIs of the world today. So you are heavily subsidized in what you are using. And I would encourage you, I think it's really important to understand where the technology is going and the impact it's going to have, but also realize that the economic model that you're building your assumptions around is likely to change. Over the last 6 months, we've seen the cost of AI skyrocket, absolutely skyrocket. Tokens are more expensive. We're getting throttled in our usage. We talked about at the keynote, going to need a double compute to keep up. So I mean, we will literally have engineers that will tell us, well, like, we're getting throttled right now. Like, our agents aren't doing what we need them to do. And I think that the industry will keep up, but it's a cautionary tale for folks in the room. And it's kind of like autopilot in an airplane. You know, a pilot's skills degrade if they get used to relying on autopilot all the time. I don't think we can afford to have that in this industry. We already are bleeding skills. So finding a way to use AI to sharpen your skills and finding a way to use AI to supplement, I think that's real. But becoming dependent on technology that you don't fully know there's a sound economic model supporting it, I think that's a lot of hype and a lot of risk.
That's absolutely right. We have no idea what these tools that we're using are going to cost next year. And it does change the economic model for software development, but you have to be very careful.
I think at a certain point, just economics will step in. Up to now, we had that steep curve to the top, but at a certain point also the cost will step in. And then at a certain point, you need to do the judgment, how much basically economies do I get out of technology, or is a human being the better option to do it at some point? And it's also about not replacing the human, but making the human more value add. An easy example is the topic of service cases or support cases, basically, where you can let basically AI answer the easy ones to add value to the important or not important, they are as important but more complex ones, and add value in that sense to your customers.
I think what's real is results, right? Results in the enterprise, the value that they create, the reality of a product performing better or getting to market quicker. And that's what's real. And I think most of everything else is hype. So we are incredibly focused on our customers' results, their speed of innovation, their speed to a result, and the quality of that machine or product proven out. You know, that takes a couple of years, right? If you think about a product development cycle, it can be anything from 2 to 5 years, right? So you have to be at it for a bit of time to get to that point. But we're seeing that our customers are seeing that, and that's when you get the enterprise value. They can quantify that, and they know that's pennies on the dollar, and then scale that. So, you know, I'm from Formula One. Only the results on a Sunday matter. Nothing else does. I think it's the same in AI or in any technology field.
I think especially when we look in the statistics also, and there are thousands of studies, but I think they are rather consistent that around about 90% of the companies believe that AI will give them a competitive advantage. But if you look how much of these companies have unlocked that potential, you're not even at half. And that's reality today.
So I think that's a good segue into our next big topic. See, this is where my job gets harder. These guys are starting to go now, which is fun. But I do want to, in the interest of time and getting to all these topics, I do want to move on to our next topic, which is to let our panel dream a little bit about where this goes. Grounded in the reality of today, we just heard about how AI is being applied, where it's creating value, and ways it's creating value, opportunity that's left on the table. And so where does it go from here? As we think about the next, looking at Scott's exponential curve of the growth of AI from earlier, right? I think it's hard to frame this in a 3 to 5 year window because I think we don't know, but I'm going to try to frame this in a 3 to 5 year window. And as you think about where the tools and technology and value of those tools goes over the next 3 to 5 years, what do you envision happening? And Robin, I'm going to start with you, if you don't mind, and just get your thoughts on where we go from here.
Well, usually we start with geometry, right? And then we try and understand how that geometry performs, how stiff it is, how dynamic it is, and all of that. So that's where AI for engineering is at now. But there are many more stages to the product life cycle, right? So there's a concept, there's the design optimization stage. That's where we're creating incredible value now. Manufacturing. Think about being able to immediately, from the parameters you set in a casting operation, humidity parameters in the room, sand quality, mixture, temperatures, flow rates, all of that, immediately predict voids in your casting, where the faults are, and whether you can bring them to the surface, address them this way, or it's a scrap part. That's reality right now. So we've already proven that in some small manufacturing operations, which are not additive. Jason, I think, completely agree there. There's an opportunity pool there that's small and still has to scale and prove its value. And then into operations, right? Think about your machines being able to not just inference when maintenance is required, but also operationally optimize the recipe for a certain tool path generation with physics in the loop. Here's the tool, here's the coolant I need. Here are my feed rates. Here are my tool shapes, my speeds and whatnot, and know the stresses in the part, the distortion, the heat that is created, and then closing the loop immediately to optimize that, right? So we see this coming here quickly, and I'm talking about a small handful of years until that is very mature and part of the normal workflow, so that when you create a tool path, that is all optimized already. You've got the best possible, fastest, best maintenance tool path that there is. So
Jason,
I think this is near future, right? It's not far future.
But it's
this
not
will
too far.
come.
Yeah, this isn't
it's not too far. This is for the next handful of years.
Jason, I think you have some thoughts on this topic.
I do. Trying to think of where to start here, Jim. So Robin, I definitely agree. I come back to over the next 5 years, as this technology increases, we go through the peak expectations down into this Gartner hype cycle, trough of disillusionment, and then we find the productivity frontier. How fast we work through that will probably be aligned with how fast the technology is evolving and how quickly it's coming to market. I think over the next 5 years, something that you can take to the bank is that the software you use, so you heard how important it is to each of our companies, the software you use is going to get dramatically better. And I think there's going to be a pretty significant difference in, do you use AI as this like LLM or out of the box to go and drop in a CAD part and say, program this part for me, generate the G code? Probably not. But I do think that the tools that are designed specifically for the tasks, you're going to see step functions in how automated those tools are. And I think picking your partners that you work with, never been more important. The underlying tech suite that you have in your business will get an unbelievable facelift. Figuring out how you structure your data, though, is really what's going to unlock your ability to make good decisions. And you should be able to see the world in your business in whole new ways. I can take our entire financial model and put it into AI, and it will tell me where to look. And it helps me do my job better. Right. That's real. And that is going to continue to get more and more impactful as long as you're capturing and structuring the data the right way.
Maybe just to your point, choosing the right partners. What we have seen a lot with discussing with partners, with customers, basically, is almost every single project, every single opportunity works with basically cleaned data. But when it comes to real data, your data, basically, on the shop floor, basically when you have shift handovers, when basically you have also PLCs which are maybe a little bit older and all these hiccups, then basically it's not working as smooth as it does when you have nice clean data which are prepared for demos. And there's, I think, the biggest friction also between a project moving from POC really and scale it in your company, or remaining on a POC basis.
Yeah, and in this country, we're unbelievably high mix. All the industries we talked about, super high mix environment, lower volumes. You have this concept of bullwhip in the supply chain, constantly thrashing. That all makes it more difficult to have the variables at your fingertips to leverage AI to the fullest. I do think that is going to change from the top down as PTC's customers start to leverage the power of AI to understand their parts, what's similar, to eliminate. I think in Windchill, you guys just announced simple deduplication of parts across platforms. Like that is going to make a dramatic difference in going from high mix, low volume, sporadic purchasing to still probably a fairly high mix, but a much more controlled volume and more predictable revenue. I think that's going to be tremendous for the industry.
Yeah. Just one more again I take my usual example in the CAM area. Certainly you can take tons of data for parts which have been programmed, but I think the real asset comes basically if you can take your own data, the mix you're driving in your company, because then it's getting really an asset for you, letting AI help you to program a part. And I think that's then competitive advantage, really.
John, I want to ask you a very specific question. I read a press release a couple days ago about Claude being able to drive Autodesk's Fusion 360. And I tried it. And I won't comment on my experience, but I tried it. I'm sure you have as well. Is this the future of CAD? Is this the future of CAM? Is this where we're heading?
So first, let me say that this is an example of the limitations of AI, because it demonstrates that you can't train AI on geometric data to generate manifold manufacturable geometries. So a different approach was used with Autodesk, where AI was trained on the APIs for Fusion to drive Fusion. And you can do that because APIs resemble language. So we'll be releasing something similar with Creo this month, more production ready. Customers have been doing the same thing with Onshape, because Onshape has a language feature script which generates geometries. So this is probably how AI will be generating geometry, by driving the CAD system, because geometry is created through very special libraries that generate manufacturable geometry. So in some sense, this is the future of CAD, but the challenge will be to make this applicable to real problems. We're working with the CEO of one of the space companies that launches satellites. And his challenge is that he needs to reduce cycle time in producing his next rocket. And he's identified some bottlenecks. Generating brackets takes CAD operators, and they've got thousands of brackets in one of these devices. doing wire harnessing is extremely tedious and time consuming, and they want to apply AI to these geometry type problems. So it could be that some type of approach like Claude driving Fusion will be the solution to that problem. Ask me in 60 days.
Yeah,
Give you the real answer.
yeah.
I'm going to come in here. I mean, I partially agree with what you're saying, John, and also disagree a bit. I think a lot of that is still in the hype phase. And when we really look at in the hype phase, so I think there's the low-hanging fruit, the repeatable, simple engineering tasks that that can be automated that way. But if we look at the complexity of real designs, right, and the assemblies that have to be created, the constraints that have to be satisfied, how everything has to be parametrically linked so that they can do optimal packaging and do that most efficiently. And also in the background, of course, think about all the manufacturability that a good design engineer always knows. And the best design engineers I've worked with, when you then take that design and you send it through a stress analysis, it comes out all uniform color. They all of that is baked into the experience of great design engineers. And to do that by agent is going to be extremely difficult. And I see that a number of years in the future.
No, that's exactly right. So there's two limitations to agentic AI that make generating geometry difficult. One is you can't train on geometry to generate geometry, and that's pure math. And let me finish these two thoughts, though. When you generate geometry, in order for the edges to lie accurately in adjacent faces, you have to intersect the faces, and that's a math operation, not an LLM operation. The second reason is that generating geometry is a highly interactive activity. Trying to describe the shape of any object, and try this with your hands in your pockets, is very difficult. So those two things mean that you need a different approach if you want to automatically generate geometry. So just generating CAD through APIs is a part of the solution.
I'm going to break you guys up. This is great. I'll let you take it outside later.
No, I'm agreeing. I agree 100% with what you said.
I just want to keep us moving along because there's another topic I want to get to here that I think is very important, and it's the topic of skills. And, I used the word fear earlier, and we've sort of, you hear a lot about the fear of job displacement and the fear of skills retraining and the fear of being able to create a workforce that's capable to work in this new environment. And as we switch gears to this, Steffen, I know you've given a lot of thought to this topic. And, do you think that the industry will experience a loss of human jobs? Do you think that the economic calculus will move from labor to human labor versus tokens? Is that where we're heading?
I give the answer at the end. First of all, when we talk with customers and also operators, basically users, then the amount of people telling us, I think my job could be affected by AI and could be also over time replaced by AI is for me amazingly high. Roughly, I would say a third of the people telling us that. On the flip side, if we look, and that's a little bit more where I believe it's going, is in the science and what different surveys say, then it's more on the flip side, basically, that it's more to augment, basically, humans to add more value to the stream. And basically with that, if you look also into statistics, and I've just read a couple of weeks ago a survey from PwC who have inspected billions of data for that. And they have basically seen that in the target group of companies exposed to AI, those who were really heavy adopters of AI, they have even seen 3 times more growing, and with that basically even increasing labor and humans. And I think we should, if we only see AI as, let's say, a tool to be more effective and to reduce cost, I think we are not jumping far enough. I think it's unlocking much more, and we should think big here, because with that I think we can get much more productive, and with that labor will increase even. And I think to answer to your question, I don't believe we will lose jobs, but the jobs will get different. We are coming from a model where the human is the worker to a supervisor, directing basically AI. And with that, I think we will see more that shift. And certainly that has a whole bunch of things on top. When I think on HR strategy, on how to hire, what are the skills we are expecting from people in 5 years, then it's a complete different story. And I think there is a lot of friction still, and also ideas how to upskill people in that direction.
So what specific skills, if my daughter or son were graduating from high school and I were trying to advise them on, what they should go pursue, what skills or education do we need to prepare this up and coming workforce with over the next half a decade or so? What do you guys think?
Certainly panel moderator.
There's no doubt about that.
The two that we're finding we need more of in PTC as we use AI to generate software are people that can write requirements in a way that can be turned into real product. Mm-hmm. And then the second is way on the other end of the spectrum, people who are architects and know what good software is and isn't, because we have to be able to judge the results with a human being. Right. So those two are in high demand within our company.
How about manufacturing, Jason?
Yeah, I think communication, I think John nailed it. Being able to communicate and articulate yourself, like if you're going to tell a computer or a machine what to do, kind of like describing geometry, you're going to have to be an expert at communicating clearly and concisely. I think what we're seeing, and you'd have NVIDIA's CEO stand up here and say, if your people are not blowing $250,000 worth of tokens every year, you're screwed. Your company's going out of business. And it's such a self-serving statement. But I do think that as the cost of AI starts to rationalize, the people that are going to be most successful with the technology are the people who know how to leverage the technology efficiently. And that's going to come to how you prompt, how you communicate, how you interact with the right model. I mean, even today, our software engineers have their pick of the litter from different models to go and try to write code with. And we can have a software engineer that infuses an enormous amount of inefficiency, like 90 minutes, 60,000 lines of code.
Right.
But it takes weeks to understand that and make sure that we're not putting critical vulnerabilities into our code base. And then we need to go build features in and around that. I mean, it can start to become exponentially expensive. So people that can articulate the problem really well and really thoughtfully, I think that's going to be an incredible skill for folks to have.
So that's a good segue into our final topic, which is the issue of trust, right? And, everybody in this room manufactures something. They commit to tooling. They commit to raw materials. There's great expense involved in doing this. The consequences are high. The output needs to be correct. The output needs to be accepted by their customer. In a world where results from AI are generally non-deterministic, how do you think about that issue of creating trust, of creating traceability, of creating results that can be relied upon day in and day out? And Robin, I'd love to start with you on this one and get some of your thoughts.
Well, let's start with traceability. One thing that's very much at the core of our platform is that there's a complete lineage of every AI model, how it has been trained, what simulation models were used, how were they validated, what's the data that they generated, what's the model quality that comes out. And yes, the model can grade itself with uncertainty metrics and things like that. So you have within that ecosystem of a simulated digital twin representation of the engineering problem, you have a way of self-verification, because that model then makes a prediction, right? And if you have any doubt, you can put that prediction back through the normal legacy process of CFD or FEA and check it. Indeed, we automate this whole thing so that it's always checked when the uncertainty is a bit low. But I think maybe slightly more generally answering the point of trust. In science, how do we build trust, right? Everything is a thesis, it's theory. Trust is built in science by the theory not being proven wrong. You cannot prove it right. And I think trust in engineering is by the results that are created on the back of predictions. And the more the results match what the predictions say over time, the more you trust that tool, right? And then you expand it, you push it to the boundary, you invariably something will fail, and you recalibrate, revalidate the tool, improve the simulation, and you build trust into the new domains. It's a long process, and I think the point of trust is incredibly important. You said things about partnerships, right? We don't throw software over the fence, right? We work in partnership with our customers to help them get to the results, build that trust, and be honest about those results where they're untrustworthy.
I think what you said is completely right. In my perspective, AI needs to earn the trust as any other technology out there as well. It's an engineering topic, basically. We validate, then basically we change something, we revalidate. That's how we work, and that's, in my eyes, also how you earn trust at the end, basically, to make sure it delivers real added value in real life, basically. On a Tuesday, in the third shift, when something breaks, then it has to be right.
So let me take this in a slightly different direction, which is the issue of model training, which we've talked about. Hang on, I see you jumping out of your seat there. I don't want you to use my data to train your models to help my competitors be more successful, right? And so how do you guys think about that, right? This issue of training a model on industry data, on synthetic data, on customer data. How do you think about that as a vendor in this space? Jason, I know you might have some thoughts on this.
We heard Scott Sawyer talk about AI principles, right? And I think you have to start with, what are you going to do? You have to communicate that broadly to your customers, and you have to explain how that's going to impact them and how it impacts the entire product. I think the challenge with working with very large frontier models is they get better by training on massive amounts of data. So they are a vacuum cleaner for data. They're trying to suck in as much as they can. They're trying to understand that, and then they're trying to improve the way their model infers answers. Mm-hmm. I think when you're working with more specialized software vendors, like, great example, we're trying to identify weld symbols. Okay, well, how many people see consistent weld symbols across their drawings, right? Like, you would think there's some sort of role around engineering and design, but that means we need to be able to leverage what we see as you're calling out welds and understand, okay, this is how this weld symbol looks, and this is how that weld symbol looks. So, but being very explicit about, it's not like your drawing is going to pop up for someone else in the platform. And I think that that's where the difference between inference and being very deterministic matters. And I think that
and helps.
That helps.
And helps.
And to your point on trust, like I think Robin and Steffen were talking about trusting the output of AI. I think there's a larger topic, or at least equally as large topic, is trusting the arbiter of the AI. Like, can you trust the company that you're working with, that when they say, yeah, our models are going to get better because you're loading data into it, that is actually making it better for you, and it's not exposing some of your secret sauce to someone else. I mean, we're seeing in more and more NDAs not to be trained on an AI, and I'm not sure if your customers are coming out to you with that, but it's like, okay, well, so you're basically putting a governor on progress in the industry because people don't know how to write rules around it. They don't know how to structure it. So I think trust is going to really have to be the relationship between who's providing you the AI and what the output truly looks like.
And it's clearly going to evolve from where we are now, right? I mean, it's a little bit of Back to the Future is what I'm seeing with, the issues around data sovereignty and people having a desire to actually lock their data, in a closed room, which no one else has access to. And I think at PhysicsX you see some of that, right, Robin?
Oh yeah, absolutely. And so there are two modes in which customers train models. We provide untrained foundation models. So these are models that are large architectures, but all the weights are randomized. It has no data contaminated with it. And then the customers train those models on their own data. And some of these architectures you can train on a few handfuls of simulation results, and they inference, and then they become quite accurate. And that's unusual. It's very different from large language models, and it has to do much with the problem space and the volume and quality of engineering data. Engineering data is high quality data. Language data is not, right? It's all over the place. And so that's one thing. Or we provide pre-trained models that are trained exclusively on geometries and data that we at PhysicsX have generated, and then the customer trains on top of that. Anytime a model has been contaminated with customer data, meaning it has been retrained or augmented with customer data, those are the customer weights. They don't go from that customer anywhere else. And again, lineage and traceability, super important. I think this is just the way it's going to be. Its data is the mode, data is the IP, and models that are created from those data represent an IP loss into another customer or competitor.
I think that's a good example of how best-in-class vendors are handling this issue and this concern. I'm just going to...
From a retention perspective, right?
Yeah,
like,
clearly.
We've got your weights, your pricing formulas. They're just yours. Don't leave us.
Right.
Brilliant.
And I think also from the data you're training, at the end, it's depending on the application, because sometimes your specific data, that's the added value for you. If it's just across the industry data, then in some applications, you're not as good as if it's your data at the end.
So we have 5 minutes left. And I would like to use those 5 minutes for you to see if anyone in this audience has any questions they would like to ask of our panelists today. And so I see a hand right here.
Yeah, it was for Robin.
Mr. Fetch, need to wait for me.
Oh, sorry. It's for Robin and perhaps for the others as well. When you talk about PhysicsX, and I don't know the company, I'm going to look into it, but you're doing design. How does AI deal with intent? I could see if I had two things that needed to be joined together, AI could probably figure out how to join those two things together. But how does it know to design the thing in the first place? Gets back to how do you describe geometry with your hands in your pocket?
So if you can formulate the intent in terms of a constraint, these surfaces have to match. I have to maintain a contact here. Or a physical constraint like the load cannot exceed that, or the displacement has to be that. We can absolutely then embed that into a model prediction and make sure that any design suggestion, any new geometry the model predicts obeys that constraint. We can search the space of all geometries and eliminate the ones that don't reflect that intent. The difficult part is the human translating that intent into something quantifiable, understandable by CAD and simulation software. But multi-domain, multi-target optimization and physical and geometric constraints, absolutely. Yeah, doing it all the time.
Don't you need a human to invent?
No, the invention is by searching the space of all possible geometries which do not violate the intent. That's what innovation actually looks like for AI. It's intelligent search of the space. Would love to show you more stuff. Yeah. And there is innovation there. There's actually new nuggets that when you then see what has been produced and you run through it in your own experience space and your own validation process, your own models, you're just like, oh my God, I now understand this new principle that has been found, understand the physics and why this new geometry now works better. And that's really cool. I mean, that's innovation for me.
Do you have another question? Yeah.
Well, I wanted to thank you guys for coming here and doing this. I know some of you have traveled really far, but bringing your wisdom and history into training, hundreds of people here, which will train hundreds more. That's pretty valuable. How would you, in your productive, but also bringing in architects who can translate that AI information, like what developments have you guys seen in getting that system started? Like for a company who hasn't started in AI yet, who's trying to develop it and begin to use it in their manufacturing experience, like getting one person to start that and then get it developed, how would you start that?
Yeah, I can. Basically, in my experience, and I've seen also already a few companies who have not yet started at all, I would not advise boil the ocean and try to do it everywhere. Have a look a little bit, where are your areas of concern, where you have workflows, where you have basically problems, and try to applicate, start there, where it creates the most value for you at the end. If you can fix by AI some problems, challenges you have in an area.
Yeah, I think every improvement in your business is going to start with a process map. Like, I beat that drum so hard at Paperless Parts, but you're not going to improve a process that you don't have outlined and that you don't fully understand the steps of that process. I would also say that you can start on the end of the spectrum of like, give everyone Claude and see what they do and burn tokens and see how innovation works. And I think that's why we're reading that 95% of AI initiatives are failing. Not necessarily a bad thing, because there's learning in failing fast. But what I would also say is, I think vast majority of the tools you already have are starting to infuse AI into the products. And enterprise software does not get used to the fullest extent. 20% of the functionality in any given enterprise suite, maybe, but the other 80. So I would say look for where AI is being applied to the products you're already using and make sure the team is capitalizing on that. We did it in sales. Outrageous improvement in sales productivity. And we didn't have to build anything.
So here's a practical suggestion. Go home tonight, buy a personal subscription to Claude for $20 a month, and use it to do something in your personal life, like generate a spreadsheet of the brackets for the NCAA basketball tournament. And then add to that a little bit more. And within 2 hours, you'll understand what you can do. And then bring that to your business life.
And I would offer just one last thought, which is think of it as a tool, not a destination, right? Yep. AI is a tool to help you do something more efficiently.
Okay.
And with that, ladies and gentlemen, we are out of time. So thank you all very much for your participation. Thank you to our panel. Appreciate you all being here. And enjoy the rest of the conference.